Welcome to the Does It Work podcast by Biomarker Labs, where you can find wellness without the woo.
There's an alligator coming down.
Today I'm speaking with Christina Shevchenko. She is co-founder and dietitian at MyWayDNA. We met a few weeks ago at the San Francisco biohacking meetup, and we're going to talk about direct-to-consumer genetic testing. More than 15 million people have already ordered direct-to-consumer genetic testing, and researchers expect that number to reach 100 million by 2021. And recently, an Iowan woman named Johnny Jindrak claimed genetic testing reduced her risk of ovarian cancer from 63 to 11% in just 2 appointments, a blood draw, and $45. Now, obviously, the risk didn't actually change for her, but she was now aware of her risk and felt a lot better. Certainly worth $45 to her. More practically, genetic testing revealed that a Texan boy named Lorenzo could stop his nocturnal epileptic seizures with a nicotine patch. His mother told the Dallas News, "This genetic testing has completely changed the life of my son and our family. To be seizure-free is a wonderful thing." So, I wanted to ask Christina, researchers are constantly updating their conclusions on what genetic variants mean for patients. Gene variants once thought to be associated with dangerous conditions turn out to be benign, and thought to be benign turn out to be dangerous. But genetic testing outfits are not required to update patients or doctors when new research comes out. Do you think this could be problematic?
Yeah, it's true that every week I think we have new research coming up and we see the new properties of genes, new interactions of genes. This is very true, but I don't think people make decisions of like having or not having babies based just on, oh my God, sorry, did you ask about the babies?
No, but that's a good point. Yeah, let's talk about
because
that.
I remember the question you asked and that's what I'm answering.
Yeah, absolutely. That's totally fine. Yeah, so the claim is that people are making big life choices based on this genetic information. So for example, a genetic test may indicate that they're very likely to have a child with a certain genetic condition. And so they may choose not to have kids based on this information. Well, what if that information turns out to be wrong and no one bothered to tell them and they should have been having kids this whole time? Do you think that's practical?
Yeah, I think that can be a problem because there is a specific test that you're supposed to take before you're getting pregnant and before you're planning the pregnancy, and it's a specific test for the mutations. It's a very good test because it can tell you your chances of getting this mutation, of passing it to the next generations. And if you do know that you have the mutation with your husband together, which puts you into like 25% of chance of passing that mutation to your children, it's a very good thing because in this case you know and you get to choose. You have a lot of options like in vitro fertilization, like sperm donors or egg donors. We have the CRISPR developing, and maybe we will be able soon to edit the genome of our fetuses, so which is a very good thing. But in case you just don't know, there's no point where you choose. So this is basically just natural selection taking place, which is more like a Russian roulette in our today's world because the science is so developed and you're supposed to make choices yourself.
Yeah, no, I agree with you. It would be great for everybody to take that test before they decide to have kids, but what percentage of the population do you think actually does any kind of genetic testing before they choose to have kids?
It's not mandatory as far as I know, but I hope that it will be mandatory soon because the parents are supposed to know. I don't know the exact percentage, but I believe around 8% of the OB-GYNs recommend that for their patients in case they have the family history. But the problem is that it's only around 20% of the mutations that we have can be tracked down to the family history, and 80% of those mutations, it's where you didn't have family history of this kind of disease. It was just a mutation in this family, the first mutation. So
you'd like to see it become mandatory for at least OB/GYNs to recommend this testing to their...
Of course, it is supposed to be, yes, because you in this case you have the control in your hands. You can choose, you can change everything.
So is this test part of direct-to-consumer genetic testing?
It's not. In case maybe because to pass something to your child, you're supposed to get 2 cells, right? It's the genome of the father and the mother. So in case the mother gets genotyped and she knows that she has a mutation in some of those genes, it's very important to give the father the test too. So, and then we can tell for sure if you are able or unable to pass the genetic mutation to your kids. If you have the mutation and the husband doesn't have this specific mutation, there's nothing you will pass. And with the mutation in both of the parents, the chances are usually around 25% only.
Okay. So is it a question of cost that this test is not part of direct-to-consumer genetic testing?
I think in a lot of ways, no, it's not that much of money, especially if you know that you will have to take care of a diseased child later if you don't do the test. But I think it's more like the genetics is rather a young science, because we only got like the first genome genotyped around 15 years ago. But it's not mandatory right now. I think it's more about that people sometimes are afraid of finding out something. And I think the problem is also in the OB-GYNs, because they don't always recommend, only if there is a danger for something. But they're supposed to recommend it to everyone, I'm sure.
Absolutely. And this is a place where, you know, MyWayDNA could lead the charge and say, we're going to include this as part of our direct-to-consumer genetic testing for people who are considering having kids or are just curious.
But for that, we need the information from the father and the mother.
Right, right, absolutely. So you could do it as a couple.
Yeah.
Awesome. Yeah. So you know, just to get back to the original question, do you feel that there should be requirements on genetic testing facilities to proactively update patients and doctors about new discoveries?
Of course, it's for sure. And if we have some changes in the some new research comes up, we always update our clients. Will always send out the emails telling that for example, their risk has changed, because what you should understand is that we're not making decisions on just one gene or one SNP. We're making decisions with a very difficult script, with the fuzzy logic what we're using, that it's the bioinformatician script that tell you the chances of getting some kind of let's say disease by, for example, 20, 30 genes. And there's your chances whether in low, in high, or in the medium. So we always update our patients and our customers. But what I should tell you probably is that most of the genetic testing right now, the consumer-based testing, is not in the medical field. It's rather in the wellness field. So they do not give you information on some serious, really serious mutations. For example, like, let's say, cancer, like over-the-counter disease. And if they do genotype you for that, and if, for example, we see that you have the mutation in, let's say, BRCA1, BRCA2 genes, which may make you predisposed to cancer, there's no way we will ever tell you to take some action, like, for example, surgically remove your breast or your ovaries. And we would probably recommend you to go see a doctor for sure, to make the test once again, so that we will not have a chance of mistake. And then discuss with your physician what your next step should be, what your screening should be, what your other actions should be. And for sure, this is something that can save the lives of a lot of women, of our mothers, of our daughters, of our loved ones. Absolutely.
So tell me more about the differences between direct-to-consumer or over-the-counter genetic testing and physician-assisted or provided, overseen prescription genetic testing. So one would be obviously the recommendations for what to do next would be different between the over-the-counter and the physician-guided. But what other differences are there?
So in case of physician-guided tests, we probably we react more. So and with the consumer genetic testing, we're more in the proactive position. So with reacting, for example, let's say you have some symptoms. So you have chest pain and you feel out of breath more. So you come to see your physician, what's wrong with you? And you walk in and he sees this very tall woman with long limbs, with long fingers, with very deep voice. And you start telling him your symptoms. I mean, you're supposed to take your cardiogram, and you take off your shirt, and he sees this chest bone which is really protruded inwards or outwards. and he starts to suspect. He asks you if you ever were diagnosed with Marfan syndrome, and you say no. So he has to order this genetic test to only genotype you for one gene to find out whether you have this syndrome or not, and also a better of other tests for sure. So this is the way he is reacting, because your symptoms and your looks, which may seem just a bit strange for other people, but the doctor sees that this is basically what Marfan syndrome looks like. And you might not be diagnosed when you were a child. So he checks only this one gene. He doesn't have to genotype all of your genome for that. He needs just this specific gene. And this is the way he reacts. He finds out whether you have it or not. And with consumer genetics, it's more like maybe you have something running in your family. You know for sure that a lot of your relatives died of heart attack, let's say. And you wonder if it's in the genetics or is the lifestyle, if it's nurture or nature. And you order the consumer genetic test and you find all of those polymorphisms, you find all of those genes, and you find a lot of information about your health. So you will be able not just to treat disease, you will be able to prevent them.
That makes a lot of sense. So speaking of ordering tests to answer questions, how would you recommend that consumers choose between the various companies that offer tests, and which tests to choose of those companies' offerings?
It depends on your goal, what you want to know. Basically, a lot of the consumer tests, if they do the wet biology itself, if they take the swab or they take your spit, your saliva, then they mostly give you the raw data. For example, if you take the 23andMe, the Ancestry, they usually give you your raw data, so everything that they genotype you for, you can use it later with other services. If you just need this raw data, then I would probably go with 23andMe, because a lot of services take their test results. It's pretty cheap. I think they have the cost is pretty cheap because they have a lot of samples, so they're able to draw back the sum of money that they require. That's what I would do. But in case you need to understand that this not be your whole genome, and this will not be your whole exome. If you need the whole genome, you can pay like around $1,000, I believe, and get this information. But what I should say is that there's not much that we can do with this information yet. There's a lot that we don't know. If you just want to store it somewhere, you can do it, but for sure in several years you will be able to do it for like $100. I think it will be much cheaper, because the first genome sequencing costed like $3 billion. Then it went down to $300,000, and now you can do it for $1,000. And in several years, for sure, I think Illumina will put it to $100.
That's a pretty good price reduction.
Yeah, so there's no point in doing it for this huge sum of money, because you will not be able to use this information in any ways.
Right. So you would recommend send your spit to 23andMe, and then take the report that they give you and send that to companies like yours.
You don't have to get the report, you have to get what's called raw data.
Raw data.
Yeah, it doesn't have any information that you would be able to use, because it only has your single nucleotide polymorphism, like the RS and the number, and then your gene variant. Okay. So you will not be able to use this information, but we will. So okay. You can download it to our service or any other service and then get your result.
Okay. Awesome. I want to talk about one more kind of political question, which is in 2012, parents whose kids have cystic fibrosis successfully pressured their school district to remove a boy from his public middle school because a genetic test displayed markers for cystic fibrosis. And they were worried that having another kid with cystic fibrosis would pose an infection risk to their children. Mm-hmm. It turns out that he wasn't even actually at risk. They had misread the genetic markers. But to prevent discrimination on the basis of genetic markers, such as this case, the Brookings Institute wants to see genoprotections expanded. So more Americans will take advantage of genetic testing without worrying about being discriminated against. What do you think about that?
I think this is a question certainly what we should raise. the example that you gave, I think it doesn't have anything to do with genetics. It's more like with some people are assholes and they can discriminate you on anything. They will find what's discriminating about your height, about your race, about the way you talk, about the way you think. So it has nothing to do with genetics, but definitely genetic information, just like any other sensitive information, it's supposed to be stored very carefully. You're supposed to protect it, and you're supposed to be sure that the third parties that you give this information to, that they're protecting it as well. And I really don't want this kind of case to make people think and to prevent them from sharing the information and from giving the information to research, and from because there's so much that we can say if you participate in a survey and if you give your genetic information. Because if we see some crosslinks, for example, I don't know, just any example, if you like cherry yogurt and your relatives died of colorectal cancer, and once in a while you get a stomachache, then if we have this same information for, like, say 10,000, 100,000 people, then maybe we can get a pattern there, and we can make a research and we can see whether those crosslinks make sense. So this is something that pushes the science, and this is something that you really should do, and this is your way of contributing to the science, not being a scientist. So the only thing you should do is carefully protect your information. And what people should understand, and a lot of the time they do not understand, is that we don't have your information. Your information is always depersonalized. So you're not like your name. My information is not Christina Shevchenko, this is her genome. It's more like 131572-DC, and that's me. So nobody knows that it's my information. It's depersonalized. So it's pretty safe to give it to the parties that give you the contract and say that they're not going to use it. What exactly they're going to use it? If it's research, if it's selling to other participants, but it's always depersonalized.
So when you say people need to be careful with their data and keeping it secure, what does that entail?
Maybe you do not want to share it with anyone, like put it on your Facebook or something, because there is your name and there is your age and a lot of the things that can give away very sensitive information. It's like with any medical record, there's nothing in our genetics more than you can find like in a medical record. For example, if somebody knows that you have a predisposition, for example, like myself, for LDL accumulation, does it put me in some position of being discriminated? Probably not. But maybe in the future we can find something in the genes that can make it like a point of discrimination. But I think it has more to do with the society itself and with the development of society. And we do know from the history from, let's say, Germany, what it can lead to when people get discriminated by their genes, by their looks, and by their like appearance and stuff like that. So I really hope that our society has moved forward and we will not be at that point. But right now it's better to secure your information and to only share it with the parties that will like protect it.
For sure. I wanted to pivot now to sleep because that's something we're focusing on more at Biomarker recently. And so I wanted to ask you, is there anything that people can gain from understanding their genome when it comes to their sleep habits? For example, maybe I could find out from my genome whether I'm likely to be melatonin deficient, for example, or maybe it works best for me to go to sleep at a certain time and wake up at a certain time based on my genetics.
Yeah, that's something you can do. For sure, there is some research for that, but I wouldn't say that we have a very high p-value genes for that right now. We didn't find it now yet, but genetics really determines a lot about your sleep cycles and about the circadian rhythms. And what I would recommend, even without doing the test, is just being more like listening to yourself, because there is this myth that you're supposed to wake up early and go to sleep early, which is really not true, because everyone is different and you get your personal sleeping cycles. So in case you're a morning person, it might be better for you to go to sleep earlier and to adjust your lifestyle to that. And if you're not a morning person and you feel much better waking up at 10 o'clock in the morning, let's say, so it makes a lot of sense to change your lifestyle so that you would be able to maybe work later and to come to work a bit later. This is actually something that we're using in our company, because mostly our working day starts at around 11 o'clock in the morning, because we know that a lot of people are very creative in the company, and they rather would sleep in the morning and work better, much better in the evening.
Okay. So from what you've seen, there's no objective benefit across the board health-wise to waking up and going to sleep at any particular time. What you found is that the benefit is going to sleep and waking up when you feel best.
It's good to have a regime. So in case you know that, for example, you're a morning person, then it's better to set your alarm every day at 7 o'clock. And which is very important. It's not, for example, what a lot of people do, which is a mistake, if they have to go to work and they have to wake up at 7 o'clock every day, the weekdays, and then on the weekend they sleep till 12, till 11 o'clock. That's very bad, because that switches your circadian rhythms, which is very not good for your hormonal system, for every part of your body. So it's better for those changes to be around 1 hour. So in case you sleep till 7 in the working days, then you're supposed to wake up not later than 8 o'clock on the weekends. And if you adjust your lifestyle to your natural circadian rhythms, it will not be a problem for that. You will be waking up at 8 o'clock anyways.
Okay, great. And so you're saying that if you get recommendations for how and when and where to sleep based on your genetic profile, be skeptical.
I would be skeptical. Yes, I would be skeptical. I would have a look, and if this is something you feel feels right, okay. But if they tell you that your natural cycle is waking up at 7 o'clock and you know for sure that 7 o'clock is not good for you, then you shouldn't follow it.
So if you get the results and they suggest something, then maybe you should test it out.
You should always have a look at the p-values. This is something that I see a lot in a lot of companies, is that they make decisions on the genes that are not that, they don't show a lot. Because, for example, even for heart disease, let's say for LDL, so we have, for example, some gene, some SNP that has a very bad p-value, and that, for example, it was tested on 10 people, and for 10 people it showed the result that 60% of those 10 people, with this variant of gene, are supposed to have LDL rising. And for example, we have another gene which was tested on 10,000 people, and we know that the p-value is very high, so it's a very good research, and the gene is showing this really. And we can't weigh both of those genes equally, because this one is not very good research, although maybe if we do more research, it will be we will see that it is working. But for this gene, for sure, the p-value is high, so we are supposed to know that this one is showing more, and it's better to judge on that. So for our company, for example, we're only choosing the high p-value genes, and we're not using those. This is why we are unable to maybe give you some traits, for example, for sleep, because for now the research is not conclusive at all.
It's a little more user-friendly. Instead of the users having to go through and say, oh, what's the p-value? You're doing the work for them and saying, we're just not going to include results that are not.
And also you have the results for every research that this is this gene. You can, if you want, you can read more about it. And this is,
And going back to the p-values issue, I've also read that this is even more of a problem for non-white people, because the data set tends to skew much wider than the world population.
Yeah, and this is true because, for example, some of the genes that are showing Some genetic risks, we should be careful about the population. Yeah, because, for example, if it was only tested on the Chinese population, that might be true for that population, but that might have nothing to do with the white European people, per se. So this is very important, and this is very important to know who you're targeting, what you're targeting, and be open about the data and showing that this was tested only on this nation, for example.
Yeah, absolutely. So anything else that our viewers or listeners should know about your company? I think you're launching yesterday. You launched yesterday?
Yeah, we launched yesterday, and we're doing nutritional genetics. So we're just having a look at the genes that are responsible for metabolism of different food components. And we tell you what kind of product you're supposed to eat, what kind of, we have a lot of recipes for you to cook, and we're telling you whether you should or should not take supplements. So this is our main focus.
Wonderful. And how should people find out more?
They can go to our site, which is MyWayDNA.com. They should have their 23andMe data, raw data. They can download it to our site and then get our reports. And I would, one of the things that I would like to also say is that, once again, I would like to emphasize that genetics is the future of every type of science, of medical science in particular. And you're supposed to not be afraid of taking your genetic test. This is something I hope everyone will get the minute they're born, because it's very important to get your genome information. And not being afraid, being open to give your information for research, because this is something that drives science, something that's very important.
Well, and it's great to do it as a baby too, because babies produce a lot of spit. So
yeah,
it'll be easy to fill up your tube.
Yeah.
On that note, thank you so much for coming in. Thanks for talking to me.
Thank you for having me.
Of course. Thanks for listening.
Thanks for tuning in to the Does It Work podcast by Biomarker Labs. For links, show notes, and more, check out biomarker.io/podcast.